We're going to go over simplifying exponents. So we've just done the two laws. So we've done the two laws. We're going to apply them to much more difficult questions. So this question here, there are many rules we're going to have to use. Just quickly looking at it, we have a power of a power. We'll then have two exponents multiplied by each other. Then we'll have another division. And maybe we even want to make it positive. We still have some negative exponents. So there's like 4 major rules to go through here. What order do we do them in? What do we follow? Okay, that's right. But what is the acronym we use? BEDMAS, right? We'll follow BEDMAS when doing this. So, okay, so according to BEDMAS, we deal with our brackets first. So like Sam said, we got to use a power of a power. So we're going to deal with that first. This becomes t to the power of negative 2 times 3. And then we'll have t to the power of 4. And it's still going to be above t to the power of negative 6. So we simplify our bracket first. Negative 2 times 3 will give us what? Negative 6, good. So we then have t to the negative 6 times t to the power of 4. T to the power of negative 6. And then t to the power of negative 6 again, yes. Okay, the next step here, because this is t divided everything by negative 6, we're actually just going to simplify the top of the fraction. What rule would we use here? It's a multiplication, so what are we going to do with the exponents? That's right, we add them. So t to the power of negative 6 plus 4. Still divided by t to the power of negative 6. What is negative 6 plus 4? Negative 2. So we have t to the power of negative 2 divided by t to the power of negative 6. What rule are we using now? Yeah, it's a division, so we'll subtract the two exponents. T to the power of negative 2 minus negative 6. What is that going to give us in the end? That's right. It's going to be like adding 6. We'll have t to the power of 4. Quite a few steps for a simple question. Now, we're simplifying this one. This one is very confusing. Not yet. So we're going to simplify this question, and I'm going to show you 2 different ways to go about doing this. Now, the first thing you want to do is you want to collect all of the like bases so that you know which ones you're going to be using rules on. There is only one base of A. Okay? So there's only one rule to apply. That's the power of a power rule. We actually have 3 numbers with a base B and 3 numbers with a base C.
So the 3 is negative?
Okay? 3 is negative. Okay? So what we're going to do here is I'm going to solve the top part first, simplify it, we'll say, then simplify the bottom, and then we'll use our division rule last on the left side. Okay? So our question again said A. Now A to the power of negative 3, negative 2, how can we simplify that? Okay, so it's multiplying the 2 numbers together. Negative 3 times negative 2. Good. We also have a base B. And this is B multiplied by another B. So what will we do with these 2 exponents? That's right, so we'll have 0 plus 5. And we only have a C on top, so we'll leave that as C to the power of 2. On the bottom, we have 2 C's, and they're multiplied by each other, so what do we do with them? That's right, so we're going to get C, 4 plus 8. That's right, and with our B value, we'll multiply the exponents. 1 multiplied by 2. So, we're going to get A to the power of 6, B to the power of 5, C to the power of 2, divided by, and C to the power of 12. Now, the last thing we need to do is apply our division rule but we have to have like bases, okay? So let's go about subtracting these. Our a is going to stay the same. We have a to the power of 6. Our b will now become b to the power of 5 minus 2. And our c will become c to the power of 2 minus 12. When we go to simplify that, a to the 6, b 3, and c to the negative 10. And if we wanted to make that positive, we would invert that number, right? So another way we could write that is to the power of 10. Okay. There's another way we could have done this. Okay? Instead of dealing with all of that division last, we could have got rid of the fraction first. So, this might become difficult, but I want you guys to think of it this way. All of these numbers on the bottom, I can bring them to the top of a fraction using our negative rule. Okay? Because we have to invert fractions, if I turn all of these exponents on the bottom negative, they'll come to the top of the fraction. So what I mean by that is we're going to leave the other things we had. We have a power of negative 3, negative 2, b0 and b5, we'll put them beside each other, and c to the power of 2. What we're going to do with these ones on the bottom, we'll also simplify the bottom before our next step to make this idea simpler to you. We know we're going to have c 4 plus 8 and b 1 times 2. What we could do here is we could have brought these things to the top by making them all negative. So for instance, sorry, I didn't want to actually split my c. I wanted to keep them two separate ones. I haven't done anything. It's the exact same question. So, we have a to the power of negative 3, negative 2. Let's put all the b's together, okay? This b here we know is going to be the value of 2. So when we bring it up, it becomes negative 2. So b0, b5, b negative 2, because that would be 2. And our c's, hold on, c2, c negative 4, c negative 8. I've now gotten rid of the fraction, and I can just use my multiplication rules. So this becomes a6, add all of these together, b3, and add all of those together, c negative 10. So that's another way we could have gone about solving this. Just depends what you're more comfortable with.